Good evening, my YouTube viewers. It is Crystal here. I'm just here to give you a code review on a natural language processing community competition because you don't have a lot of competitions on natural language processing. So I decided to go ahead and do this. And just to tell you a little bit about my personal life, I was in pool for Easter, but I couldn't tell anybody that I was in pool because I was afraid of what I might come home to if I told anybody I was in pool. And I was using my boyfriend's Chromebook, which he doesn't have like an Xbox player on his Chromebook. So I was using a free online screen recorder. And so that's why the recordings that I did were different. And also, because I was in a house full of people, I had to be quiet so I could do my videos early in the morning, but I couldn't do them during the day when people were up because, I didn't know how they would take me giving videos. So this is a program that I worked on last night, and I finished it this morning, or I worked on this morning, and I finished it this morning, and I wanted to give you a code review for it. And so it's a community competition with Kaggle, and it's the Comment Crush competition, and I'm using a RNN, a recurrent network, a recurrent neural network. So I did the program on Kaggle's free online Jupyter notebook, but Kaggle is also owned by Google. I got a public score of 80 on this one, which is good. It's like the highest public score that I've got doing natural language processing. And that's another reason why I wanted to do a code review on this as well. So we'll talk about the problem statement. The competition aims to classify whether or not the sentiment associated with a particular comment is positive. It is of instrumental importance to the service industry. With the advent of emojis, it has become even more challenging to identify the correct meaning of a comment via machine learning models. So the first thing that we did was we imported the libraries that we were going to use. We were going to use NumPy as NP, which is to create NumPy arrays and do numeric computations. We were going to import Pandas as PD to create data frames and perform data processing. We're going to import OS, which is operating system, and that gets into the operating system. And we're going to import RE, which is something like called regex expression, which is to do with natural language processing. We're going to import string, which is to do with string processing. We're going to import matplotlib.pyplot as PLT, which is for visual computations. And then we're going to import Seaborn as SNS, which is for visualize the data, but with statistics in it. We're also going to import sklearn to perform machine learning functions, and we're going to import Tensorflow to create the neural network. And after we have imported our libraries, then we're going to use OS to get the files. And we're going to get 3 files. One is test upload, one is data set, and one is sample submission. And then we're going to read the files using pandas and convert those files to train, test, and submission. So we look at the train file. You see you have an ID and then comments and positive. And some of these on the train file, some of them are missing. You have some null values. So we check train info, and you can see ID is an integer, comments is an object, and positive is a float. check to see if we have any null values, and yes, we do have null values. So we drop all of the rows where we have null values. So now we only have 1,814 rows as compared to 1,926 rows. So we had to get rid of about 113 rows because I just didn't want to worry about imputing them, because we have no way of knowing whether positive is going to be a positive or a 0. So I just went ahead and deleted the rows that had null values. We're going to check the disk plot against positive, which is your target, and you can see that we have more zeros than we have ones. And so with positive, we have 1,020 zeros and 794 ones, so we have less ones than zeros. We have 2 unique values, which means this is a binary classification. Now we're going to check the test data set, and we've got an ID and a comment, but we don't have a positive because that's what we're going to be predicting on. And then we have the submission file, which is an ID and a positive. Now what we want to do is we want to prepare the data set. So X equals train comments, X test equals test comment, and Y equals train positive. Now we're going to use sklearn to split the data set into training and split the X and Y values into training and validation sets. So X train, X val, Y train, Y val equals train test split, X, Y, test size equals 0.1, random state equals 42, shuffle equals yes, and then we check the shapes of those. Now we're going to go into Tensorflow. So what we're going to need to do is we're going to need to import Tensorflow and all of the different modules in Tensorflow that we're going to need. You need to also print off the version of Tensorflow, because Tensorflow goes through a lot of modifications, and so you need to know what version of Tensorflow you're working with. Now we're going to convert the Pandas datasets to Tensorflow datasets. So xtrain ds equals tf dot convert to tensor xtrain, xval ds equals tf dot convert to tensor xval, ytrain ds equals tf dot convert to tensor ytrain, yval ds equals tf dot convert to tensor yval, and xtest ds equals tf dot convert to tensor xtest. And now what we're going to do is we're going to vectorize the tweets. So we're going to define a function called custom standardization that's going to take the input data, and so it's going to be a lowercase equals tf.strings.lower input data, stripped HTML equals tf.strings.regex replace lowercase, replace the break with a space, return is going to be tf.strings.regex replace stripped HTML of these values, and it's going to be replace it with a space. Now we're going to have max features is 10,000, so that's maximum columns is 10,000, and sequence length is 250. So text vectorizer equals layers dot text vectorization, standardize equals custom standardization, max tokens equals max features, output mode equals int, output sequence length sequence equals sequence length. And now what we're going to do is we're going to define features equals xtrain ds, text vectorizer dot adapt features, and you have to use that adapt with this. And then we're going to check the vocabulary vocab equals np.array text vectorizer.get vocabulary, and then you look at the first 20 words of the vocabulary, and you can see what the first 20 words are. Now we have a function called preprocess x, and then return text vectorizer x. So now we check encoded example equals text vectorizer x trained dx. The first 3 examples, I'm going to make it NumPy. This is your encoded example. It's coded example for the first 3 examples. So for n in range 3, print original x trained ds in NumPy, print round trip, comma, space, join.vocab encoded example. So this is going to be your first 3 rows. And so you have an example of the original, what it looks like, and what it looks like after it has been processed or vectorized. Now what we're going to do is we're going to define our model, which is going to be a recurrent neural network. So model equals tf.keras.sequential. Then text vectorizer is going to be the first row of the column, first row of the model, and then it's tf.keras.layers embedding, input dim len equals text vectorizer get vocabulary, output dim equals 64, mask 0 equals true, and then the next row is tf.keras.layers bidirectional tf.keras.layers lstm 64. The next row is a dropout, tf.keras.layers dropout 0.2. The next row is dense, tf.keras.layers dense 64, activation equals reclue. The next row is dropout again, tf.keras.layers dropout 0.2. And the next one is dense, tf.keras.layers 1. And so the 1 means that there's only 1 column in the target. And now we're going to compile. After we've created the model, we need to compile it. So model.compile, optimizer equals FM, loss equals losses.binary cross entropy, from logics equals true, metrics equals accuracy. And now we create a summary of the model. So you can see a summary of the model. It goes from the text vectorization. It says 0, embedding is 248960, bidirectional is 66048, dense is 8256, and then dense again is 65. So it gives you the total params, the trainable params, and the non-trainable params. And so what we have now is we have plotted a model of the sentiment classifier. So this is just a model that's been plotted out. And we plotted a model of the sentiments classifier with shape info. So we plotted that out. And now we're going to train the model. So epochs equals 30, early stopping equals early stopping, monitor equals val loss, mode equals min, patience equals 25, verbose equals 1. MC equals model checkpoint, and it's best model.tf, monitor equals val loss, mode equals min, save best only equals true. So history equals model.fit, xtrain ds, ytrain ds, epochs equals epochs, validation data equals xval ds, yval ds, callbacks equals early stopping in MC, and verbose equals 1. So we train the data, and we have early stopping at epoch 27. So now we define a probability model equals keras.sequential, and then it goes to the model, and layers.activation is sigmoid. So we save our model as comment model. Now what we're going to do is we're going to predict on the test set. Predictions equals probability model dot predict x test ds. Predictions equals predictions dot flatten, and then you've got your predictions. And then I played around with it a bit because I tried to get the best score that I could possibly get. So cutoff equals predictions max minus predictions min divided by 2. And then predictions equals NP where predictions is greater than cutoff 1, otherwise it's 0. And then so you see your predictions is a bunch of zeros and ones. So I did a Seaborn plot of the predictions, so you can see a plot of the predictions, and then you can see the number of values that you've got on each one. Count pred equals np.unique predictions, comma, return counts equals true. So count pred is the unique, the predictions is 0 or 1, and you have 81 zeros and 69 ones. And then after we've done that, what we do is we prepare our submission. Submission positive equals predictions. Submission to CSV is submission.csv index equals false. Submission equals pd.read CSV, submission CSV, and then you've got submission. So we've got our submission data frame or a CSV file that we are going to submit to Kaggle for scoring. And when we submit it to Kaggle for scoring, I got an 80%. And so I was so pleased with that, I decided I wanted to do a code review on this. But unfortunately, I couldn't do it right away because I didn't want people to get upset that they would have to be quiet. So let's go to the leaderboard. So I'm number 2 out of 3 on the leaderboard, and I had 7 entries. So my top score is 80. So that was good. I mean, the number 1 score was 87, and it was a base ML. I don't know what they meant by that, but it was base ML. So that was it. That's my code review. I'm going to go ahead and complete this this code review because I've covered everything that I wanted to cover. But what I would like to say is I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And thank you so much for watching this code review. I look forward to making more code reviews for you in the future.